information is going to outnumber the authoritative maps. These are authoritative, like somebody has published them. These are just, me and you putting up pictures and tweets and whatever. Now, this is going to dominate almost to the scale of 1:100 in the next 5 years. That means if there is one authoritative map, there will be hundreds of unauthoritative maps of this nature. When you have crowdsourced information which is not authoritative, there are huge number of applications right now that, for example, Twitter being an early warning system for many kinds of disaster. Then there is the aspect of community GIS. Now this is semi-authoritative in the sense that this is sometimes created by school children, sometimes it's created by a community of fishermen. It is sometimes created by a community of drivers. Waze is completely outsourced. Okay, this is an application that people in the US use for driving from one place to the other. Now what does Waze do? Takes information from the drivers, processes it as intelligently as it can. It takes information from government agencies, official blockages and all that, puts it together, and hence gives you a driving guidance. Now, what happens in this? The map that Waze develops, it found out many routes which did not exist earlier. Why? Because there was blockage, people found routes and these came into the... So these are the things that come into community GIS, which is a community has developed it. It is partly authoritative because the community will stand up for it. There is a band of users that use it regularly. So as compared to authoritative maps, sometimes they are more usable. Pooled data. Now this is something that has transformed things forever, and we will have a video about that. I mentioned about Google Earth engine. Now Google Earth engine, what did they do? They put in huge amount of satellite data, all kinds of satellite data from 1978 or 79, or in some cases even earlier than that, to till date. And you have this spatio-temporal data set. So one problem in Bhutan, for example, is to take satellite imagery. The cloud cover doesn't prevent you to take satellite imagery during huge amount of time. But if you have satellite imagery from so many sources, you can do some intelligent mining and take away the cloud. You can, get the unclouded satellite images of Bhutan. So these are the amazing things that you can do with pooled data, like a large set. The other one is vehicle traces. How many records do I have of people driving on the roads? If I collect 1 year of data, I will know a lot more than any government agency will survey. You will know average speeds, stopping points, scenic views. You will come to know, if you look at those data, for example, in our lab we analyzed bus movement data for 30 days. Okay? And you can find out where are the places which are not bus stops but the buses stop. And which are the bus stops, designated bus stops, but buses don't stop. There is another class of data that was never used in traditional GIS. Okay, there is this building information models. These are basically information about your buildings itself. These are typically, they were the CAD drawings. Now CAD and GIS community never mixed together. Okay? But now it has changed, and we will see how it has changed. And this is being integrated because for the end user, it doesn't matter what is GIS, what is CAD, doesn't matter. If I want to get from my hostel room to the classroom, I need a map or information, whatever, you can call it whatever, I just need to go. That is my use case. So, now if you stand, I don't know, have you been to any tower somewhere where they had, like, you could take your camera around and get a 360? The images are stitched. So, this is what you see in Street View of Google. Now, but the technology is increasingly competitive. That's a very, very interesting niche area. Many people are innovating. Okay, they want high resolution, panchromatic images, wherein you can actually measure distances and you can see the things, and they are very accurate in terms of location. LiDAR is a laser-based surveying system. Okay, what they do is they shoot a laser beam and it comes back. So you know how far that point where it reflected, they know. And so they get this multiple points. Now this laser light is shot like I think around 7 to 8 times in a second. So it goes very fast and it goes all around. Okay. So you get a profile of all the points from where it has been reflected. So you have a, now they combine this with 360-degree panorama. So now you actually have the entire surrounding of every place accurately, never before. This is centimeter accuracy, geospatial data streams. Now, many of us are aware of data streams, right? So what happens is, just in case, like a GPS feed, okay? If you have the latitude coming along with the latitude along whatever read you are taking. So for example, it is in cases of the 360-degree panorama, the car is going, right? The car is moving with taking images, but the latitude is changing. So that is also feed, live feed. Now these live feeds, tweets, snow cams, so all these are now being processed, and this is difficult to say that this is GIS anymore.